would argue there's some urgency in doing that. So for the benefit of this broad audience today, Farhang, maybe you could just say a few words about ASCE4 and how a new concept transitions from new concept into a formal code guidance and how that process works.
Sure, David. I've been on ASC4 and ASC43 committee for a number of years. And these two committees are fairly active. Every 5-6 years, they update the codes. And we have to cope with the changes, new technology, new changes all the time, actually. The way it works, any new idea that comes in, it will be reviewed carefully by the committee and see what the studies has been done, what the studies and research are behind this to support this new development. And the committee, small groups in the committee may choose to also make a different independent assessment of that with respect to some of the projects they have in mind and report back to the group in a different session. So it's a process that the committee goes through to accept this new idea by, I would say, careful evaluation. And it's only then that is posted for voting. And where there are 30 committee members or so, depending on the time, and it needs to get the 2/3 approval before it's accepted and then written up in the code. So it's a rigorous process, but I have to say the ideas that have been well developed, justified, they have documentation behind them, end up being accepted. It's not that people are receptive to changes and better solutions all the time.
So just as part of this discussion, with the cadence of the operation of the ASCE4, for example, what would be a typical introduction to voting and actual assimilation in the code in terms of cycle? Would that be a year? Would that be 2 years? What would that be?
Yeah. Well, if you don't mind, I'll show you my presentation for critical facilities. The process we have in place is quite different. Time history comes at the very end, actually.
Okay.
We deal with the spectra throughout the process, and then we have also a set of, I would say, stringent criteria for time history generation. So I think I've been thinking about this, and I prepared a few slides that how this new development can get into the codes and standards, and I have a few suggestions. Time history, I have to say, is going to be a bit tough, David, in my view, because like I said, most of the assessment and adequacy of ground motion are based on acceleration response spectra. Mm-hmm. And it's expected the time history to match the spectra. There are cases where we get to nonlinear analysis. You talk about the ASC 716, whether they have 7 sets or 11 sets of time history. But even there are requirements that the response spectra of this time history, or at least on the average, come back to the ASC 7 spectra. So I think it takes more than giving time history. It needs to show that the performance goal of the structure as outlined in these different codes, whether it's ASC 7 or 4 or 43, is going to be met. That performance goal is cast in concrete. And so this time history, actually, they have to measure up to meeting the performance goal. Otherwise, it's going to be a bigger battle, really, to change it.
Okay. But I guess my question on this, and we'll let you get into it a little more, is, even if the change is accepted or entertained, it's a significant time duration to get through the committee, right?
Yeah, I mean, frankly, one of the last paper Professor Alan Corner wrote, and I can send you a copy. He, there are so many criteria as to how to select the seed time history, and there are different rules set up there. But he showed in his last paper that if you just use synthetic motion, but plenty of it, you come back to the same solution as opposed to using actual recorded seed time histories. It was very interesting. but he had to use like 30 or 60, I don't remember, to show the results on the average really would be the same. So I think the simulated motion will be used, but we have to connect the dots, especially when it comes to performance goal, and show that this is still can be met, whether it's synthetic or not.
Okay, very good. Um, uh, let's see, how it seems to me that that's an opportunity for peer to think about in terms of developing a push for code implementation. I just want to
Uh,
mark that down.
I totally agree with you, and it it kind of reminds me of the peer involvement in P58. I mean, that was the research in performance-based earthquake engineering that was embraced by the community once we peer start working with ATC and FEMA to produce this 7-volume document, and we should certainly take advantage of that. A statement like what you mentioned from ASC 7, you actually see in papers. People also quote the same thing. I remember reading a paper or two of Jack Baker some years ago, who also used the same quotation from ASCE. So researchers and peer researchers are cognizant of that, but how to really make the big impact on the profession, I think it's a great opportunity for peer. And as I said, and the timing is right. I mean, there is already activities, there is uh, and I know I ask you this, there is some uniqueness also of peer getting involved into that. I mean, the synthetic records and all that has been around for a while, and other organizations are doing good work there. But there is something definitely unique about the peer community to get behind this.
Yeah, I think this is an issue that might be important to handle in a timely fashion, in my view,
Right.
if we're really serious about transitioning this into practice. So just a thought. Um, let's see. I wanted to give Jeff Bachhuber an opportunity to give us his thoughts. And Jeff was gracious enough to prepare a slide. And Jeff, we'd like to hear from the PG&E side. And honestly, the reason that I sort of got onto this was the dialogue that you and I had when we were talking recently about synthetic ground motors. And you said, yeah, but, you said we've got a regulator that's looking over our shoulder and is always, evaluating us, and getting regulatory acceptance is going to be crucial. So I'd like you to just take a few minutes and speak to that, if you would.
Sure, sounds good. Can you hear me okay,
Yep.
David?
Yep.
All right.
Perfect.
Yeah, so you just went through some of the key elements to bring simulation into practical implementation, and Farhang had some good comments on that, and also Khalid before the break. That was a great presentation. I'm going to tee up some perspectives as an industry end user, and hopefully this will foster some discussions. A key mission of my PG&E Geosciences group is to bring new technologies in for improving our risk models. And we have been working hard to have a consistent platform where we have all of our electric system and our gas system in a single risk model. And this allows us to look at potential cross-cutting types of impacts. The better that model is, especially the hazard input to that, improves our ability to identify areas where we have a higher hazard, particular facilities where we would want to be focusing any type of mitigation or further risk assessments. We view simulation, dynamic rupture modeling, as a developing technique that's a long-term effort that we would like to bring in. It's part of our drive for continuous improvement of our models. And some particular application areas are to more accurately develop risk scenarios for emergency response, better assessment of risks, so we could really focus our efforts on areas that we should be prioritizing that have a higher risk to our system. And there has been a move more and more to have holistic type of lifeline assessments. FEMA, Cal OES are really trying to drive agencies and owners together. So rather than looking at just our own assets, really looking regionally, how are they interdependent? And I think any type of improvements to better evaluate and predict risk and impacts to the facilities will help us move towards that direction. Some focus areas for practical implementation that I brought up here are to continue the validation studies. There were some great presentations yesterday and today about efforts to do that. Integration of near surface soil nonlinearity. San Francisco Bay Area has our greatest density of both gas and electric customers and infrastructure with highly variable geology and structure, and also soft soils. And so being able to confidently bring that in as part of the process is really important for us to apply these types of models and approaches. Eventually being able to facilitate increased efficiency, laptop applications just makes this a more realistic way to apply these different approaches. You mentioned, David, regulatory acceptance. That's key for us. All of our facilities, gas, electric generation, dams fall under regulatory oversight. They have pretty old, traditional, deterministic based risk assessment approaches that they're expecting. So when we bring in new technology, we do need to compare and first educate them, bring them along, compare the results from new methods that we're applying to existing traditional types of methodology. So that's really important. I think an effort to reach out, educational outreach, and bringing in regulators to forums such as this really will help inform them and have them realize the value that could be brought by advancing approaches. I will note that FERC, Federal Energy Regulatory Commission, is now really pushing owners to start to implement risk-informed decision-making. And so the doors are opening up. Like you said, David, toes are in the water. There is an opportunity, and I think there will be improved acceptance as we drive to bringing in some new approaches. So there is a way to do this. It will take some concerted effort, though. And we always are dealing with financial challenges. You know, we're a regulated utility, as is SoCal Edison, SoCal Gas. And so we need to have our budgets approved by the California Public Utility Commission. And there's always a competition with other external hazards. So right now, wildfire is huge. For PG&E, for example, that really is our highest risk. It is exponentially higher, orders of magnitude, than concerns about seismic events or seismic risk. And so that is a challenge to still keep some visibility, some efforts going towards seismic and other types of geohazard risks. Also, there's always a drop of kind of concern or awareness of earthquakes as we get further and further between significant earthquake events. What we try to do is whenever we have an earthquake that has some impact, such as Ridgecrest earthquake a couple of years ago, is to evaluate that and also bring that information in awareness. And so it is part of the discussion and continued awareness about seismic events, trying to keep promoting that. So those are a few of the points I wanted to put out there, and I'm interested in any questions you may have, if there's any areas you'd like me to drill into a little bit deeper.
Any questions or comments for Jeff? Norm, any follow-up from your standpoint and understanding the domain?
Sorry, I'm muted. Start my video. The regulators are all trying to go to risk-informed decision-making. They don't know really how to do it. So I think there is an opportunity to try to set the framework for what you want to do. In particular, this gets to how do you make regulatory decisions when there's large uncertainties in the results. And currently we use mean values, right? Mean hazard, and we charge forward. But as you go to risk-informed decision making, you need to start to look at the underlying uncertainties. So I think there'll be more on that, or more interest in it, but there has to be some, you're going to have to give the regulators some suggestions on how to do that. They're going to need help rather than just hoping they figure this out, because FERC was supposed to switch to this 7 or 8 years ago, right, to risk-informed regulations, and it's been very slow. Sometimes this needs some key retirements for these things to move forward. But I would suggest looking at this on the regulatory side from a really broad perspective of how do you give them the tools that they actually need to make good decisions.
Farhang, would you mind going through your slide set?
Sure. Is it still open? So, David, I actually followed what you asked me, tried to see what avenues we can look into for bringing this new development into the codes and standard. So I look at it from industry perspective and the ASC committees I serve on. So first, frankly, I've been in contact with this development for a number of years, and I see significant progress, actually. It wasn't too long ago, we could only analyze the model for half a hertz or 1 hertz. Now, with better solution, efficient algorithm, and computer power expanding continuously, I believe we have reached 10 hertz or maybe more than that. Pretty soon, we are going to cover the full range of frequencies that we are interested in engineering. As you know, in the East Coast, frequencies goes up and up to 50 hertz or so before we get to the peak ground acceleration. So it depends on the location. So I do see some promising notions from this approach that could even help what we are doing right now and improve it. And I'd like to point to those points. First observation is, as was discussed and presented by many speakers, this approach requires tons of data, starting from fault and fault rupture to regional geology, topography, geophysical data for the whole region. And every time we deal with data, we have variability. Some of them are natural variability, some of them we just don't know. And we have to deal with that. And I'll give you an example. I happen to be working on a project this week in a state where we have not done any site-specific PSHA work. So I decided to use USGS seismic map. And I used both 2014 and 2018 maps that have been published. I came up with the spectra. Then I said, let's compare it USGS with the 2 other sites where we do have PSHA done, one in the east and one in the west. You have to see that comparison. It's vastly different. At one site, one is significantly higher than the other. At the other side, it's significantly lower than the other. And it really speaks to how aleatory epistemic uncertainties are handled in this ground motion calculation. And when you look back at this data set that is needed, the handling and simulation of variability becomes pretty important. And of course, you always need the judgment of experts. And in this case, would be experts from geoscience areas and seismology, multiple areas that have to provide a sound judgment, actually, as to how you process these variabilities. I think I may be repeating Norm here, but I do see verification and, more importantly, validation, the key here. The more we can correlate with the data we have with the fault seismic setting and rupture that we have recorded motion for, the more it's going to shine, frankly, and perceived by the community. So I know we have done some, but the more we do, the more weights it really adds to this new methodology. Now with that, let me tell you what we do in the industry for critical facilities and see how we can come in with this new approach. In a nutshell, in one slide, typically we do a PSHA work under a highly regulated shock process. Usually shock level 3 is used. And what they do, they often come up with a hazard at a basement rock, which could be at shallow depths or at very deep depths at the site. Then we go through another rigorous process of site amplification to transfer the hazard from rock to the elevation in the soil we are interested. Then we have to assess this spectra we are getting at multiple depths and look at the cliff, if you will, in the hazard curve, make a correction to the spectra to go from uniform hazard spectra to design spectra. So there are multi-step process to arrive at the spectra. We have abandoned, as you know, performing vertical site response analysis. In the previous workshop, Pierre, you and I presented some results that showed anomalies associated with P-wave propagation. So currently industry using empirical relationship for V over H. So once you have the horizontal spectra, you convert it to the V, vertical spectra. Once these are set, and if you choose to do time history analysis, then now they require you to develop 5 sets with very specific criteria for matching and also looking at the energy content in PSDF of these time histories. And after all that, you can then apply it to the analysis. So with that process in mind, at least for critical facilities, I see few opportunities that this new development can help. This is going to be a step by step. It's not going to be, in my view, that at this time, with limited VMV, people will say, okay, we use this approach, we get the motion spectra, and we are done. It's going to be step by step over a number of years. One of the things that I personally have been bothered by is the assumption of the wave field. When the fault ruptures, and I have seen some results showing how the wave propagates toward the site, whether they are all actually vertical waves, surface wave, other body waves involved in this, we don't quite know. Once we get the hazard at the site for the basement rock, we simply use vertically propagating waves to amplify that motion to the soil. This assumption is likely to be very conservative, especially if you're not too far away from the fault. And I think that can be looked at in relative sense and see whether we can capture the nature of the wave to some extent at different distances from the fault, and whether the assumption of vertical propagating is a good assumption or not, or overly conservative. We have given up on vertical spectra approach. We don't believe in P-wave anymore. In fact, some of the researchers believe that most of the vertical motion is caused by reflection, refraction of shear waves coming in an angle that cause the vertical motion. I think that can, this approach can help really to shed light on the nature of the vertical motion and see what is causing that, what is behind that. It cannot be P-wave, all pure P-wave. We already know that pure P-wave has come and gone before we see the shear wave. So it's something else. And that can be helpful there. So I think, as I said earlier, the codes and standards committees are receptive for a study that well-researched, well-founded, and can fit into the performance goal that they have in mind in the standard. So I think these areas, we can provide the studies that show that some of the assumptions we are making are not truly realistic, they are going to be receptive in light of doing these analysis for the site to allow other considerations, frankly, for development of the design spectra. Yeah, I think that is all I have. So I see avenues for this development to come in. I do emphasize validations is very important. It goes a long way to even pick up this idea, frankly, by different code committees. And then I think people can champion these various elements to wedge into the standards and codes and go from there. I think that's all I have, David.
Thank you. That's very, very helpful from that perspective. Any panel comments on this, or any comments from the audience? You could inject them into the Q&A.
Yeah, David, should we promote anyone who is interested in audience to the panel so we can have an open?
Yeah, absolutely. If somebody wants to chime in and raise their hand, I
Yeah.
think it's a game in this session.
Yeah, please raise your hand, and we'll open up things so you can speak, open your video, anything. Anyone in the attendees, please go ahead. And there was a comment from Swami Krishnan. Khalid, you can see it in the thing. Actually, I can give him permission to talk so he can ask directly.
Yeah, that would be fine. Yeah.
Yeah, I just saw it. You want me to read it, or he's gonna read it?
We can ask Swami. You can unmute and you can ask your question or comment.
I can read it. It's actually not a question. It's a comment. He says, I think peer taking the lead in developing, hosting, and curating a simulated ground motion database is extremely positive development. This will greatly enhance the chances of buy-in within the practicing engineering community. As we all know, data from large earthquakes in urban regions is sparse, and preparing for these events, getting our building stock updated to realistic hazard levels prior to the big one or ones requires us to use the best available information and simulations. And simulations are the next best to actual observations. All power to peer to push this into practice. Thank you, Swami.
Thanks, Khalid. I was just having my very late dinner thanks to the conference, so I'm in the East Coast now. So thanks for reading. By the time I got to the to the mic, it was too late. So thanks for taking care of the comment. Yeah.
No, it's a great comment. Thank you.
Yeah. Let's see. I thought a few more slides to maybe elicit some discussion or to make a few more points towards the end of the day here. And, one of the things about a forum like this is we all get together and there's really great discussions. And then there's not always follow on. And so I had offline discussions with Peer and some of the other organizing committee members. And we came up with a few ideas about how we might begin to push this idea beyond the confines of this particular workshop. And I just want to share those ideas with you for thought and discussion. Number one potential tangible action going forward would be the creation of a synthetic ground motion working group for performance-based earthquake engineering. And this seems like something that is something that the Peer Lifelines program might have interest in. And I think there's a number of things that we discussed that might be valuable here. Number one is to establish a clear picture of what constitutes success for utilization of synthetic ground motions. And how do we measure progress towards that goal? And that's something we discussed. Number two, develop a plan for characterization of uncertainty. Number three, identify early compelling use cases to evaluate PBEE utility for some early successes. And I think Farhang just described one. Simulation, end-to-end simulation could shed some light on the classical assumptions of vertically propagating waves. So that would be useful. Identify and promote performance-based earthquake engineering requirements to the earth science community and to reach back. And I think if we recall early in this meeting, Rob Graves made a very good point. When we started talking about the number of rupture scenarios we would need to characterize risk, he said we need more feedback from the engineering community about what parameters are causing the damage to their structures, so we can link that to our understanding of parameters in our rupture models and so forth. So that would be an important function. Then I think what we just talked about is promote accessibility to appropriately vetted synthetic motions. I think that's really, really important, and we see that from the response of the community. And then there could be an element of this working group to communicate the status of synthetic ground motions for performance-based earthquake engineering in an unbiased way to the stakeholder communities. And much as Peer did with performance-based design, they could carry this message out to the stakeholder community. So that was a dialogue that we've had. Norm or Hala, would you like to comment on the interest in this type of a working group going forward?
Well, I'll certainly let Norm chime in. I think having a working group as such is very important. Having this done under Norm's leadership, since he is the director of the Lifeline now, is the right thing to do. Hopefully he's willing to do that. And Pierre will do everything possible to make this happen. Especially I see from these polls that at least this group of attendees supported the idea, which is very encouraging. I would need to, if we're going to put resources into this, the proper course of action is I need to take the outcome or the resolution of this workshop to the research committee and let them make a final decision on that, and we proceed. That's a straightforward process.
Norm or others, any thoughts on this?
My main thought is we need to get started. So I think getting a database of synthetic ground motions that we have reviewed is straightforward and can be done. This shouldn't be a working group that 2 years from now we're still talking about how to get something happening. So my main issue is get something going, and I think this will grow once you start to give access to these motions and people can look at them. There's other comments about getting feedback from the community, like are they easily accessible or searchable? The databases are going to be bigger. It's not a few thousand motions, it's now 100,000. So I think Morgan said they had cut SCEC down to 600,000 motions or something like that. So there's going to be a problem of dealing with the size of the data that we need to address. But I would focus on making some progress, in the next 6 months, not in the next 2 years.
Yeah, so you led to my next slide. Thank you.
Let me say just one thing. I totally agree with you, Norm. And let's do the following. Let's say in the next peer annual meeting, January 2022, let's take that as a deadline for us to present the beta version of this database. And then we seek input and we make improvement as time goes by.
That sounds like a good deadline, and it's doable.
Yeah, so that was my next slide, and this is something that we've obviously talked about as well, is our DOE funded project is generating synthetic ground motions. We would be more than happy to be a guinea pig in sharing some of those motions with Pierre now, early on. And we actually have a new project from DOE, from the Office of Energy Security, that goes beyond our exascale computing project, and some funding to actually begin to transition some of this technology into practice. And so we could legitimately, under that project, work with Pierre to deliver synthetic motions. I think the Pierre project we heard about from Floriana and Norm would be a nice corollary to this. They're already developing 4-part acceptance criteria to begin to apply. And that's in the early stages, obviously, but that an investment that peers already be making that would tie right into this nicely. And so in my mind, it's under number 3, coming up with some of the schemas for how we compress, because we compress all of our data so that we reduce the size tremendously, and then you go and fetch it. And we've developed the tools for that compression and that fetching, as well as linking engineering codes, as long as they're set up in the right reference frame with the ground motions from the ground motion simulation. So we would be certainly interested in and willing to cooperate with peer on this activity. And I think it's something that could be done sooner rather than later, as Norm suggested. Any comments on that one? Okay, Norm had one more, and which is, I think, related, but it's a little bit different than the database. And that would be a tangible action of actually, piloting the first phase utilization of 3D simulations in a risk calculation. And Norm, you should talk a little bit about what you might envision here in terms of, dipping the toe in the water for this as well. And this in the theme of, not admiring the problem and getting busy and actually doing something.
Right. So before we run risk, we need to be able to run hazard, right? So I would start with a focus on getting the data so that we can implement 3D simulations, the existing ones, into a hazard calculation. So bringing them into the ground motion model so we can actually run hazard and start there. I would then, as the second step, start to run the risk calculation. But we're back to getting started, and this first thing needs to happen, right? Is this to get this validation done? I would start with the small magnitude events that are well recorded to demonstrate that the 3D velocity model is leading to improved predictions or no worse predictions than what we're using with our empirical models. That has to happen before we can move anything to practice, right? So I think that's the first step. I would like to see, something on the order of 20 small events modeled with the 3D velocity model. While those data are used to derive the velocity models, it's mainly on, a lot of it's on timing, right? Seismologists work a lot with arrival times to adjust velocities. We're more interested in amplitudes, and they're related, but they're not always the exact same thing. So we can accept errors in the timing as long as we get the amplitudes right. Mm-hmm. So if we could get let's say 20 earthquakes, small magnitude earthquakes that can be used to demonstrate the improved predictive power or the predictive power of the existing 3D velocity model. Because my concern is that the velocity model may have enough limitations in it that it's not, is it not making things better, or at least in parts of the velocity model, it actually doesn't improve the fit. And so trying to figure that out in terms of how we can find some areas to start to implement working parts of the model and say, how would you get this into hazard, and how would this would be a case to team up with PG&E, because they've got enough facilities that we can look at saying, how would this information improve our estimates of the hazard at their sites for a large number of facilities. And we could say it's improving it in this area. In another area, the velocity model isn't advanced enough to provide improvements. But that's how I'd like to get started, so that we actually get something all the way to some calculations.
Great.
And Morgan, how does that fit with what you're thinking?
Well, I mean, you're saying use the 3D simulations to validate the observations. I mean, it just seems to me like we've heard of a number of issues, like characterizing the source of small magnitude earthquakes and everything else. I certainly support the idea of validating with.
In this phase one, we're not trying to get the absolute level of the amplitude, but the path effects.
Mm-hmm.
So we can live with some mismatch with the source properties of the smaller events, as long as we're seeing the right spatial distribution of the path effects.
Okay.
Because remember, that was going to basically take the GMPE and then say we're going to adjust it for path effects from simulations, not jumping all the way to the amplitudes from the simulations as a way to move this forward and get something we can use. Very similar to what you're doing with the 3D Basin effects, right? A little more broad than that, but similar in scope as a way to move forward without jumping too far and having too many difficulties, and then you get nothing. So
Yeah. I mean, our thinking is first just validate the basin scaling as kind of the most fundamental step, and then look at the spatial variations in basin amplification from the simulations and try to validate that with small magnitude data. And
yeah, so we're trying to jump to, I guess, that second step of the spatial variation. Is the 3D velocity model in its current stage or form able to predict the spatial variations better than a model that that more accurately than just the regular old ground motion model?
Right.
About that, right? And we have to show that before I would use anything like this on a project.
Yeah.
I guess another advantage of small events is that the model can be smaller.
Can you speak up, Farhang, or get closer to your mic?
Yes, I guess the advantage of a small event is that the model can be smaller, so we can run quite a bit of them.
Yeah, the source is smaller. The model may not be a lot smaller. The main advantage is we have data, right? I think that's a fundamental thing, because we need data to validate, and that's where the most of our data with the spatial coverage we're after is gonna come from smaller events.
I do not have a fee for how long does it take. For example, this model for Bay Area was shown. Is it a day run or a month run? Or?
I'm sorry, repeat again.
I'm asking about the computer time, Dave, for running a Bay Area model.
Oh, well, we can run the Bay Area at 10 hertz in just under 7 hours right now.
Oh,
with a of, we've really, we've tried to not only increase our frequency resolution, but make sure we can run these models fast for this very reason. So we can run 10 hertz with a VSIF estimate of 500 meters per second in 6 hours and umpty minutes.
Very good.
And we can run obviously we can run a 5 hertz simulation much more rapidly, but.
I do agree with Norm. I think we need to go step by step, and we need to correlate with the recorded motion to the extent possible. We don't obviously expect a close match, but it has to be reasonable. And see what else can be done to the model to calibrate.
Any other thoughts on this topic? So I guess I still not clear. Does the working group sound right to help move this forward? Thinking of actionable items? Seems like the working group could plan.
I want the working group to actually work in an efficient way, right?
Well,
we're not just be a bunch of meetings, right?
Yeah, we're presuming the working group would do something. That's a boundary condition.
Working group which works fast.
Yeah.
I appreciate the sense of urgency. That's why we're having this discussion. So that 10 years from now, we're not still talking about what are we going to do to advance the practice. So.
But part of getting things done in a quick way is not depending on a whole lot of volunteers.
Yeah.
Right. So we have to find some way to get adequate funding for people that are involved in these working groups. Yeah. And so forth. So.
Well, so I'll make the point again. We have DOE funding to cover our activities for advancement to practice. So we have some funding, some effort we can put against this. So we would offer that as collateral for any activity that peer has. Okay, any questions, any additional questions on these topics from the audience? Sounds like there's an interest in aggressively moving forward. I just had one more topic. As we thought about this, and I've raised this with Norm and Holland a couple of times, is, as of right now, the ability to execute these types of simulations is kind of held within the research community to some degree. And I think it would be useful for the longer term to have a discussion about what does a sustainable operational model for regional scale simulations look like? And who does that? I mean, you know, you're going to have a multidisciplinary team of people that develop consensus model inputs in some sense. You have to have high performance computing. You have to have data archiving, community access. I think we have a solution for this potentially. We just talked about it at Peer, you know, but long term, who does this? Is it a national lab? Is it a university? Is it a nonprofit? Is it a multi-institutional team? That vision is not clear in my mind. And I hate to bring up and admire problems without any suggestion for solution, but it seems to me that over the long haul, this is something that needs to be thought about because these simulations are going to have to be done in a way where the code is verified and validated to the degree possible, maybe even has some QA pedigree because you're going to be doing, you know, calculations are going to be doing important things in a safety sense. So it just, in my mind, as we go forward and following on from this meeting, there should be some thought and discussion about this and what this model looks like going forward. You know, certainly the national labs and agencies like USGS have some capabilities to run these things, but is that the right model? I don't know. But it seems to me there should be some discussion about how some of this technology can be leveraged and transferred into a model that can do these efficiently and reliably, not in a research sense, but in a production sense, and QA and store and archive the motions very reliably. So it just seems to me this is another future topic for the longer term to have a discussion about. Okay.
David, can I ask a question about this? I mean, is your vision for this use case that there's an existing velocity model? Because that's, you know, obviously a huge part of this whole effort that is it just, you know, continuous effort almost.
Yeah, I absolutely agree. And the velocity model is what it is, right? And we heard this week that there's some improvements, but there's no immediate plan for some of those improvements getting in, right?
Mm-hmm.
And so to me, part of that discussion and strategy is, you know, what do you do about that? You know, to increase the frequency of these simulations, do you, you know, stochastic geology inclusion maybe helps a little bit, maybe some inversions. I don't know, but that's got to be part of the overall discussion, clearly.
But a sustainable a plan to regularly update the velocity models needs to be there, as opposed to funding an individual researcher and saying, let me know when you have something, right? It's got to be more organized than that. With like your building code maps, you know, there ought to be either a 3-year or some cycle for updates on the velocity model that considers all of the validations that have been done in the meantime and new data that have been collected. But I think less than 3 years may be too infrequent for something like this, at least at this point. I think improvements can clearly be made, and I wouldn't want to be stuck with the velocity model that we know is having problems in an area and say, sorry, it's going to be 10 years before you get a new one. But I think that's part of this bigger plan of something that will actually live on, you know, and how do you make a model have periodic inputs or updates that are using like the GS best science at the time, and trying to keep improving that as we go along.
And I think in my mind, Norm, just like any, you know, any sort of control, you would have change control process, right?
Right. Yeah.
You know, you just wouldn't have individual researchers willy-nilly tweaking with the velocity model. You would have a baseline model that everybody knows that is there. It's version 1.1.0, and there's a very deliberate process for updating that model.
So the SCEC community velocity models are, you know, a good platform to follow. I mean, a plan to follow. They've done a very good job of updating things, but with careful version control, and that's what really needs to happen.
Yeah, you know, to my mind, maybe what's a little different here is, you know, the broad engineering participation in this, so that whatever pops out on the back end is well tailored to performance-based earthquake engineering. So I think that's maybe a new part of the dialogue here.
So I think this will it's unlikely that we'll get to in 5 years that on a project people will come to Peer and say, I'm going to run 3D simulations for my site. But is that what you're expecting or thinking as
No.
opposed to researchers using
I
this?
think people will come to Peer for the data.
Okay.
My question is, in a sustained fashion, who's going to be doing the analysis and running it in
Right.
back?
Okay. Generating more simulations.
Generating more simulations. I mean, that again, that could be a national, the labs are really good at high performance computing and they have tremendous resources. Maybe that's part of the equation, but it just, to me, to make this a sustained foundation for hazard and risk assessment, you have to think about these operational issues, and otherwise you're just going to have little one-off things going on, and it's not going to be a critical mass or a sustainable effort. So I'm just raising this issue. I hate to raise and admire the problem, so without a solution, but I think it's worth raising this issue with the community.
It seems to me that engaging the labs is necessary for that sustainable operational model. Whether the labs have the interest to carry out all the research details, that's a question.
Well, the labs would have the interest. The question is would DOE be a sustainable funding source? And we've been quite lucky in getting strong support from DOE. There's a possibility if the argument's made correctly and strategically.
Also, Dave, there is the other issue. I remember the lab can do a great job. They have done other programs, as you know, a number of labs. But industry coming to the lab often runs to a lot of critical contractual issues.
Yep.
And the fact whether a lab can work on a commercial project or not is not very clear. So access to that would be difficult.
Yeah, I don't think that's the role for the labs if the labs are part of this. I think the role for the labs is working with other governmental agencies and nonprofits, to make something like this work. And that would be the most logical way to engage the labs. Because you're right.
There's the basic improvements that need to be happening right on the models.
Yep.
And running new sets of simulations and creating them. I think the engineering project that comes and says run them for my particular case is going to be a different kind of a model here. Right?
That's a different model. Absolutely. Yeah. But if it's, for example, let's just say if it's for running the Bay Area for the greater good, and updating hazard calculations for the Bay Area, that would be something that would be, potentially doable without conflict or huge effort. So anyway, I don't have a good answer for this. I think it's important. I think it's an important part of the long-term discussion, and it's, this is not as on the critical path as some of the other things that we talked about just a few moments ago. This and this. And this, but it is an issue to at least think about in my mind. Jeff, are there any other comments you want to make if you're still with us, Jeff Bachhuber, along these lines?
Yep, how's it going? Not really. As we have been, we are really interested to keep promoting this. As I mentioned, it's a kind of a long-term down the road where we can really start to implement it reasonably, I think. And to Norm's point, I think we still do have to bring along the regulators. But PG&E on our side is willing to keep, supporting this, looking at the long-term benefit we'll get from it.
Okay. Howard, I've expired my slides.
Yeah. I lost you for a second, David.
I said I've expired my slides that we talked about, so I think I'm done.
Okay.
I just
Yeah,
want.
I have. Go ahead.
I just wanted to get these very practical but important operational issues on the table for thought, because they're going to have to be confronted in order to move this forward. They're just going to have to be. If you really want to move this beyond an R&D activity into a practitioner activity, in my view. That's my personal view.
It's been a long day. Are we near finished?
We're finished. I think we're in the wrap-up mode.
Okay.
There was one comment on the chat box from Swami about engaging National Seismic Hazard Mapping Program.
Sure.
Swami, if you want, you can directly.
Right. So I was going to just say that I was wondering whether this could be absorbed under the National Seismic Hazard Mapping Program, because if it can be, then they could budget for the velocity model updates as well. And of course, for this to happen, there has to be buy-in from the engineering community, knowing fully well that this is actually going to directly get into the building codes at some point. And so this whole idea that peer being the sort of the cog in the wheel is very important, I think, because it can make it happen. Peer is the only organization can actually make that happen, that buy-in aspect of things. So to answer David's question about where can this reside in the long term, I think it would have to ultimately get into the, shouldn't have to go into the same mapping program that we have for the codes. It has to get into the same line of funding, I think, isn't it?
Well, it would certainly seem that USGS would have a role in the velocity structure development in one way, shape, or form, obviously. To me, Morgan, I don't know what your thoughts are. And
yeah, I mean, it potentially could. I haven't seen the investment from USGS in the type of, multidisciplinary teams to do kind of large scale. Yeah, I mean, it potentially could. I haven't seen the investment from USGS in the type of, multidisciplinary teams to do kind of large scale computational models. There are certainly individual scientists that are involved. Rob Graves is heavily involved with SCEC, but from my perspective, in the U.S. at least, it's the national labs and SCEC who are working together for these large scale simulations.
Yeah. I just have a couple of final comments, and then I'll let you wrap up if it's okay.
Sure, yeah.
Very briefly, I just wanted to make a couple of comments, and I think the presentations were absolutely great from all the speakers, and everybody really did a great presentation, and they adhered to the time or schedule, so that was really wonderful. I think our organizing committee spent a lot of time and care developing our invitation list for the speakers. And we had a lot of debate and discussion about that. And I think that really paid off. So I really want to thank all of the presenters. For this problem set, there's clearly a great value in getting the earth scientists, the geotechnical and the structural engineers together in, quote, one room, if you will. So I'm hopeful that through peer and other organizations, this dialogue will continue with this multidisciplinary group. And I think that's really great. The organizing committee is not done. I don't know if they know this yet, but we're going to continue after the forum to capture and document some of the key themes and talks that we will then deliver to peer as part of this project. And since peer provided some support, so we'll be doing that. And then finally, I think in my mind, hopefully
not tonight, right?
Not tonight. No, we'll get tonight off.
Okay.
And I will say, in the spirit of moving forward, I hope that this forum represents the beginning of an ongoing series of discussion and activities for peer in this area. And so I'll just leave with that thought that I think peer can help here, much as was just said in integration with the engineering community. And I think that's an opportunity.
Thanks, David.
Hiroshi-san has a question in the Q&A. If Hiroshi-san, you can ask directly if you want.
Okay, I think it is great to have those kind of database for engineers that download and use. But when they use this information, they need also the occurrence of probability of these synthetics attached to the events because they need to select either the criteria to be used as once in a lifetime or 1/10 in the lifetime of their buildings. So how do you consider to attach this probability of occurrence with each synthetics? Because the probabilistic approach, all the occurrence of each event are aggregated into the single spectra for the recurrence rate specified by 475 years, once in 475 years and once in 2400 years or something. So it's easy for engineers to choose the damage criteria for each specified spectra. But when we distribute these synthetics, they also need this kind of information for the occurrence of each strong ground motion.
I don't think that that's how we're thinking of going at it. The ground motion data set provides options for people to use given that they have a design spectrum already, right? So they've done their hazard calculation, they have a design spectrum, and they can, the first part is just being able to choose some simulated ground motions that go with their design spectrum and the scenario from the deaggregation, as opposed to only looking at recorded ground motions. So I don't see that we have to start assigning rates of occurrence to these. If you're gonna though go to later on just running things like CyberShake, where there's a rate of occurrence and a time series, and from that you're going to calculate the hazard directly. That's what we're looking at sort of in phase 3. Then you would need rates of occurrence to attach to the different models. But we're starting out a little slower than or not going as far as what you're describing. Does that make sense, Velocity?
Okay, so eventually we need to specify the occurrence of probability of occurrence for each synthetics that we will provide to engineers in the phase 3 implementation.
And essentially, it would be the rate of the scenario that we get in the normal seismic source characterization, and if the randomized values are, if the time series are source model is equally likely, it would just be, if I had 30 synthetics for a scenario, then each one would have 1/30th of the rate of the scenario by itself. But that's a ways away, because then you need the CyberShake type of thing with millions of simulations, and initially we're not going to try to go that far, because we're going to be bridging between sort of hazard results from a normal way we do hazard calculations to time histories that we can grab from the simulations. David, does that meet with what you're thinking, or are you thinking all the way to the CyberShake type calculations?
To me, who's that addressed to?
To you. So when we think about,
well, I wasn't specific. I'm just thinking about whatever direction this takes as a result of. Did I just get cut off?
No, but maybe I can say, I think the main value is going to be making the simulations accessible to people so that they can start to look at them and get familiar with them and what they do and what they don't do.
Yeah,
they'll be comparing those simulations to their current design spectrum, right? That's what's going to happen initially. And then we want to be able to run hazard using more of the features from the simulations, right? That would be, let's say, phase 1, bringing that into the hazard calculation as it starts to sort of change the spectral shape, let's say, for a particular area that might amplify 3 seconds and de-amplify, 2 seconds or something like that. But
Yeah.
just getting people to start to use them and look at the simulations is the first step.
Yeah. And make the data available.
Right.
Yeah, I'm sorry, my screen blanked out. It may be an omen. My screen went black. I think it's somebody trying to tell us the meeting's over.
No, it's no problem from Zoom side. Yeah.
Okay. Well, Holland,
May I speak?
Sure.
I think if that is the case, it is very important because I'm concerned about the one class SMORA event at the same fault. In the current long-term prediction for active fault, they only consider the kind of largest earthquake generated by a single determined fault. But the probability with the SMORA case within the same fault is much higher than the occurrence. And at some sites, those SMORA event, one class SMORA event may create the same level of ground motion. And that is not included in current Japanese way of probabilistic approach. So if the database is created by considering this kind of occurrence with the SMORA event within the same fault segment, that makes quite a sense and a good information for engineers that engineers have to prepare for the ground motion with the SMORA magnitude event, even when we consider the same level of probability of occurrence.
So we deal with that by in our probabilistic hazard calculations, right? So as I said, initially, you would have the same design spectrum that we're getting right now, and we just would say you're trying to design for a magnitude 8 earthquake in San Francisco, rather than grabbing simulation or recorded ground motions from a bunch of magnitude 7 earthquakes and scaling them up. Let's give people the option to be using magnitude 8 simulations, right? To specify what the time series is that goes with their design spectrum. So we would cover that by just the normal way we're running hazard that includes a whole lot of many more small events on a fault that with its own variability, and that may control at one particular case. But if we're getting all the way to the last phase, then you have to be doing the simulations not just for the biggest events, but the 3D simulations for the range of scenarios that might control the answer. So okay, I think that's several years down the line, but that's ultimately what we'd like to do if you can get the volume of simulations up to the kind of numbers like what CyberShape does.
All right, are we done?
So,
Khalid, you have one more slide, I think. Slide 6.
Yes.
Oh, okay.
Since I had this slide for a while now, so I am not gonna try to read it. I'll just make some comments just to remind ourselves that in day one, we talked about synthetic motions, we talked about geotechnical modeling, we talked about structural regional scale simulation, and today we had very good talks on validation metrics and acceptance criteria, characterization and propagation of uncertainties, and then the last session, which I participated in, is how to move that effort on the synthetic motion to be adopted by a larger community. I agree with David that presentations were great. I would like to thank Amarnath and his team, Erica, Christina, and Gabriel, who help a lot in this workshop. They don't get to be seen, but this is how all the work progresses smoothly. So I just want say, as David said, this is not the end of this forum. I would like to see the possibility of having a sort of a peer report coming out of this forum with some maybe sharing your presentations and putting it in a document that can be useful to those who didn't have a chance to attend. We will make the videos available, and we will include some of these summaries in the report. Three more comments I want to make. I think these polls were very useful. We already talked about the first one, which identified the interest of this group in developing this database. But there were also equally good ones that identified gaps that is very important for an organization like PEER to know what is the feedback of the community of where are the elements that we should push for in our research agenda. So there will be also a collection of these. I know Amarnath is keeping track of all these results. So hopefully that will be part of the report as well. Couple of last comments. I think from a peer point of view, the two big action items would be the peer, for a lack of a better word, fast working group to be mobilized so they can plan the strategic path for the synthetic ground motion database at PEER. And possibly also PEER should go after a pilot project in the spirit of the phased-in approach that Norm has mentioned, so we don't have to run before we walk. So this pilot project could be between Equisim and PEER, so we can develop a pathway for the inclusion of their synthetic motion in the PEER ground motion database, the new database to start with. And if we set a deadline to present that to the community on the upcoming PEER annual meeting, which is about 6 months from now, I think that will be a great goal to go after. With that, I thank all the speakers, all the organizers, and thank you very much. Anything else, David, Amarnath?
I just want to second the thanks to the peer group. They've been absolutely phenomenal. And, they really made this a seamless operation for a large number of people. So Amarnath and crew, thank you very much.
Thank you, David. Thank you, Khalid. I have just a couple of comments. Well, thanks for the last group. This was the toughest